let's look at something quickly that we never had time to go back to in a more exploratory manner, but we'll just look at it quickly. It's similar to the story for reflection for parabolas, and the GeoGebra software makes it pretty convincing. We've got an ellipse. It's got two foci, and I think of a light ray coming out of one of the foci. So imagine there's a light source here. Sound also works. And it comes out, and it happens to be going out in this direction and bounces off the ellipse. And we've talked about how we're modeling that basically as if it were bouncing off the tangent line, which I've drawn in here. And depending on exactly what, which light ray coming out here, bouncing off here, light ray here, bouncing off here, we want to know if there's something special about what all those light rays do. And so you might be able to guess just by eyeballing, is there something special they're all doing? They're definitely not all going to be parallel, like for a parabola, but it turns out that I claim they all will go to the other focus. Let's go back and we'll measure the angles in a second. Certainly, if it goes straight right, it'll bounce back straight left, go through the focus again, and end up at D. If it bounces right off the top, you can see that's a nice isosceles triangle, everything's symmetrical. That's pretty reasonable. But the much less trivial stuff is in between, where I claim that it's going to bounce off any one of these points and end up at the other focus. It's a very beautiful story. Again, similar to the story with the parabola. Let me put in those angles. I'll have it measure the angles here. And we can drag E one more time, and you can see those angles are exactly equal as it goes around. And so that confirms that the reflection property of an ellipse is that any light ray coming out of one focus and reflecting across on the ellipse gets reflected to the other focus. And so there's a lot of like whispering galleries that architects like to create where this is done with sound waves. And if you stand at C, the sound that you're generating gets refocused at another location at the other focus of the ellipse. So let's look at what that is, the corresponding thing for a hyperbola. So now looking at a hyperbola here with foci at C and D, I've had the program draw the tangent line there, and once again I can look at various points. And so here what I'm going to have, this one is the least obvious of the three in terms of guessability. This one tends to be a bit hard to guess, but I'll give you a hint that the start of the excuse me process is, instead of something coming out of one focus, I have a light ray that is going towards the focus C. And I'm imagining really a lot of light rays that are all focusing towards C. Then you might think, why would I get that? Why would I get a bunch of light rays that somehow all know where to go? Well, the way we're going to get that is they're going to be coming from a parabolic reflector that will be reflecting parallel light rays from a distant star or stars, and they will be on their journey to all go to the focus of the parabola. Now, what we're going to do is we're going to intercept that before they get to the focus with a hyperbolic mirror. And the question is, do they do something nice when you do that? And indeed they do. And so this is a good time to kind of look at this and sort of try to eyeball, where are they going to go? I haven't drawn the reflected ray yet, but it's coming in here and it's bouncing off this tangent line. And now I'll give it away. They all refocus at the other focus of the hyperbola. So that's pretty cool. And let me convince you, at least if you believe the software, you can see here's that incoming angle. That's what it's calling alpha, at top angle, like 58.76. And then that's the angle of incidence and the angle of reflection. And it's verifying that those are equal. no matter where it comes in. So if it comes in kind of perpendicular to the transverse axis, it's reflected in exactly the right way to go over to D. Of course, if it's going along the transverse axis, it just gets reflected exactly back. That's pretty easy. But it's this magic shape that if they were going to converge at one focus, you can change their mind and say, oh, we still want to focus somewhere. We still want to all go to one point and accumulate and concentrate the light, but we're just going to go in a different place. And that is very, very useful. Now, you might think, well, wait a minute. Now they're going to reflect off this guy and get reflected back. We're only going to use one branch of the hyperbola for the mirror. So we're going to use here, you just use the right one and not even use the left hand half. And so there's nothing for it to go to hit. It just goes straight to that other focus. So a very cool property for both ellipses and hyperbolas. And of course, parabolas had the most famous one. They all have lovely reflection properties.